Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to show you the solutions to the arithmetic reasoning practice test on my website. In case this is your first time finding my YouTube channel, I want to mention that I recently created a website called mastertheasvab.com. There, in addition to taking 5 practice tests, you can also find resources such as formula sheets, which should help you do your best on test day. All that said, let's go ahead and get started with today's video. Question 1 says, Technician Smith makes $14 an hour. When she works more than 8 hours a day, she gets overtime pay of 1.5 times her regular hourly wage for the extra hours. How much did she earn for working 11 hours in one day? So the first thing I want to point out is that she makes $14 an hour whenever she works 8 hours, and she makes 1.5 times her rate of pay for everything else. In this case, we're told she worked 11 hours, so that means she worked 3 extra hours for her overtime pay. To calculate her overtime pay, we're going to take 14 and multiply it by 1.5. Which looks like this. In case you haven't worked with decimals in a while, the key to doing decimals is to get rid of the decimal. You shift this over 1 to make 1.515, and at the end of this problem you're going to add the decimal back in. So in reality you're doing 14 times 15, albeit with 1 decimal to add back in at the end. 4 times 5 is 20, carry the 2. 5 times 1 is 5, plus 2 is 7. Add a 0 since we're starting this number. 1 times 4 is 4. 1 times 1 is 1. Let's add. 0 plus 0 is 0. 7 plus 4 is 11. Carry the 1. 1 plus 1 is 2. We have to shift our 1 decimal back in, which we do like that. So we know her overtime rate is $21 per hour. Now what we're going to do is multiply these together and then add them, because she works 8 hours at $14 an hour and 3 hours at $21 an hour, so we need to add those together. So let's do 14 times 8 right here, and 21 times 3 right here, and then we'll take these results, as I said, and just add them together. 8 times 4 is 32. 8 times 1 is 8. 9, 10, 11. 3 times 1 is 3. 3 times 2 is 6. So we see that we have 112 plus 63. Let's go ahead and do that here. Just going to look like this. 2 plus 3 is 5. 6 plus 1 is 7. 1 plus nothing is 1. So we can see that in total, including with her 3 hours of overtime, she would make a sum of $175 for the day. Okay, so that's that one. Nothing too difficult about that one. I will say this, and I intentionally did this. The practice test on my website increase with difficulty for each one. So the first practice test is fairly easy. The second one's more difficult. The third one's slightly more difficult than the last one. And this one is actually one of the more difficult practice tests on the website. So if for some reason you're struggling with these problems, my advice to you is start with AFQT practice 1, work your way into practice 2, practice 3, practice 4, and then this one. In so doing that, you should develop the skills to handle these problems pretty easily. Okay? So number 2, the clerk is writing a budget request to upgrade his personal computer system. He wants to purchase 16 gigabytes of RAM, which will cost $100. Excuse me. 2 new software programs at a cost of $350 each. A backup system for $249. And a pack of writable CDs for $25. What is the total amount the clerk should write on his budget request? So we know the RAM is going to cost $100. The software is $350 a piece, and he wants to buy 2 of them, so that's 2 times 0, that's 0. 5 times 2, that's 10, carry the 1. 3 times 2 is 6, plus 1 is 7. So those 2 new pieces of software are going to cost $700. A backup system for $249, and a pack of writable CDs at $25. Let's go ahead and add these up. 9 plus 5 is 14. Got to carry the 1. 4 plus 2 is 6, plus 1 is 7. 7 plus 1 is 8, plus 2 is 10. So we can see that if the clerk wants to submit a accurate budget request, they should include the total of $1,074 in it. Okay? So far everything's been straightforward, but the problems are going to ramp up here pretty soon. All right. Number 3 says, the secretary spent her 35-hour work week in this manner: 1/5 of her time sorting mail, 1/7 of her time filing letters, and 1/2 of her time typing. The rest of her time she acted as a receptionist. The percentage of time she spent as a receptionist during this week was most nearly, so we know she did 1/5 sorting mail, plus 1/7 filing letters, plus 1/2 typing, which sounds like fun. And then she spent the remaining time as a receptionist, so I'm going to represent that as X. And we know that her total time can be represented as the whole number 1. So in this case, we have to add fractions, and to do that, since all these denominators or bases are different, we have to put them over a common factor. That is, we have to make all the denominators the same. And we don't have to do that for the X. Okay? So we have to find the greatest common factor of all these. I know 35 is a factor of 5 and 7, but 35 is not a factor of 2. It doesn't go in it evenly. So I'm going to double 35 to 70, because I know 5 goes into 70, 7 goes into 70, and 2 goes into 70. So let's go ahead and put these all over 70 so we can actually work with them. Now, you can regard 1 or any whole number as just a fraction over itself. So instead of writing 1, I can actually write 70 over 70 if I wanted to, because this is the same as 1, but that's not necessary at this point in time, so we're going to hold off on that. So now we ask ourselves, how many times does 5 go into 70? If you can't do that in your head, you can do it off to the side. 5 goes into 7 one time without going over. 5 times 1 is 5. Subtract. 7 minus 5 is 2. Drop down this 0. 5 goes into 20 4 times. 5 times 4 is 20, so we can see there's no remainder. So 1/5 is the equivalent of 14 over 70. Okay? 7 goes into 70 10 times, so 10 times 1 is just 10. And 2 goes into 70 35 times. 35 times 1 is 35. Okay? So now we have to add all these together. And I'm going to do that off to the side here, since it's not necessarily easy to do it in your head. 4 plus 5 is 9. 1 plus 1 is 2. Plus 3 is 5. So all this is 59 over 70 plus x equals 1. At this point, we're trying to solve for x. So what I'm going to do is subtract 59 over 70 from both sides. This crosses out, and as I said, I'm subtracting that from both sides. We're left with x equals 1 minus 59 over 70. And I'm going to go ahead and erase some of this because I didn't anticipate these fractions being this difficult, but just bear with me here. Sometimes you get in the fractions and they just become very messy, so let's go ahead and make some more room. Now at this point, I'm going to rewrite this as this. X equals, again, 1 is the same as 70 over 70. 70 over 70 minus 59 over 70. So let's go ahead and do this. Again, when you add and subtract fractions, as long as the denominators or bases are the same, you just subtract the numerators. So this would be 70 minus 59. We can't take away 9 from nothing. So this has to become a 6, and this becomes 10. This is 1, 1. So this becomes x equals 11 over 70. Now, as you can see, this would be our answer choice if they gave it to us in fractions, but instead they gave it to us in terms of percents, which adds another step to this problem, unfortunately. And then the next step to finding, to converting this fraction to a decimal is to regard it as long division, namely 11 divided by 70. So we got, grab my pen here, 11 divided by 70. Now we say to ourselves, how many times does 70 go into 11 without going over? It doesn't. 11's too small. We have to add a 0. By adding that 0, we have to kick up a decimal right there. Now we ask ourselves, how many times does 70 go into 110 without going over? That's 1 time. 70 times 1 is 70. So we're going to go ahead and subtract. 0 minus 0 is 0. 11 minus 7, 7, 8, 9, 10, 11. That's 4. Now the question is, how many times does 70 go into 400? And if we think about that, that's the same as asking this. How many times does 7 go into 40 without going over? 7 times 5 is 35, whereas 7 times 6 is 42. We don't want to go over, so we know it's going to be 5. So I know 70, in light of the fact that 7 times 5 is 35, 70 times 5 is going to be 350. And we can go ahead and subtract. 400 minus 350 is 50. Okay, and we have to add a 0 now because there's one that drops down. Now we're asking ourselves, and at this point we can't decide whether it's going to be 15 or 14 or 16%. We know it's not 6%, we know it's not 26%. But that said, depending on what this next decimal place is, it can either round down to 14% or up to 16%. Well, it can't round down to 14%. So we know it's going to be 16%. So that said, let's go ahead and work this out one step further to see that this does in fact round up. Now we're asking ourselves, how many times does 70 go into 500? Well, 7 times 7 is 49. Therefore, I know 70 times 7 will get you 490. And as we can see, this now becomes 0.157. We look right here and see this is a 7. So this is going to kick this 5 up to 6 to be 1.16, which is the same as 16%. Again, a very simple problem, but in light of the fact that the fractions were messy and we had to understand that fractions can be written as decimals and whole numbers can be written as fractions, this one got pretty involved. And at the same time, we also had to be comfortable doing this very basic mental math to make our long division quick and painless as possible, if long division can even be quick and painless. So that was that one. Again, you should start feeling as if this practice test is requiring you to be pretty solid in your fundamentals, which is the point of practice. Okay, number 4 says 6 cups of flour are required to make batches of cookies. How many cups of flour are needed to make enough cookies to fill 12 cookie jars if each cookie jar holds 1.5 batches? So the first thing I'm going to do is find out how many batches are in all 12 cookie jars. So I'm going to take 12 and multiply it by 1.5. This will tell me how many batches in total I'm going to need. And as we did in one of the first problems, when we multiply a whole number by a decimal, we shift the decimal over. In this case, we're going to shift it one time to make 1.515. And at the very end of the problem, we're going to shift that decimal place back in. So in reality, we're doing 12 times 15, albeit with one decimal to shift back in. 2 times 5 is 10. Carry the 1. 5 times 1 is 5, plus 1 is 6. Add a 0. 2 times 1 is 2. 1 times 1 is 1. Let's add. 0 plus 0 is 0. 6 plus 2 is 8. 0, nothing plus 1 is 1. Let's shift our one decimal back in. So we know that in order to fill 12 cookie jars, which hold 1.5 batches each, we're going to need a total of 18 batches of cookies. Or 18 batches. We know there are 6 cups of flour per batch. So we're going to take 18, multiply that by 6. 8 times 6 is 48. Carry the 4. 6 times 1 is 6, plus 4 is 10. So in total, we're going to need 108 cups of flour to fill up all of those, to make enough cookies to fill up all those cookie jars. Okay? All right, let's move on. At Frank's, let me get rid of that. I don't know why that's highlighted. At Frank's Italian Grill, the hourly wage for a chef is 20% greater than that of a dishwasher, and the hourly wage of a dishwasher is half as much as the hourly wage of a manager. If a manager's wage is $8.50 per hour, how much less than a manager does a chef earn per hour? So we're given chef, a dishwasher, and a manager. And we have to go through the dishwasher to figure out how much the chef makes, because we're told the chef makes 20% more than the dishwasher, and the dishwasher makes half as much as the manager. So we know the manager makes $8.50, so we're going to multiply that by 0.5, which is the same as 1/2, to figure out how much the dishwasher makes. Once we figure out how much the dishwasher makes, we can figure out how much the chef makes. And then once we figure out how much the chef makes, we can figure out how much less the chef earns than the manager. Okay? A lot of steps, none of which are too hard, but you have to go through the hoops to get this one right. So we're multiplying a decimal by a decimal. I'm going to shift this decimal twice to make 8.50 to be 8.50, and I'm going to shift this decimal just once. So in total, I shifted the decimal place 3 times. In reality, I'm doing 8.50 times 5, albeit with 3 decimals to add back in at the end. 5 times 0 is 0. 5 times 5 is 25. Carry the 2. 5 times 8 is 40, plus 2 is 42. Shift our 3 decimals back in. 1, 2, 3. So we know the dishwasher makes $4.25. Again, the manager makes $8.50. Again, we know the chef makes 20% more than the dishwasher. So we're going to do 4.25 times 0.2. This will tell us what 20% of 425 is. We're still going to have to add that to 425 to figure out how much the chef makes. 5, and again, we're dealing with decimals here, so we're going to shift this 1 2 times and shift this 1 time. So in reality, I'm doing 425 times 2, albeit with 3 decimals to add back in at the end. 5 times 2 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. 4 times 2 is 8. Shift our 3 decimals in, 1, 2, 3. So what this tells us is 20% of 425 is 85 cents. So we have to add that to 425 to figure out how much the chef makes. All right. The key to adding decimals is just to drop the decimal in place. You can add a 0 placeholder here if you need it. 5 plus 5 is 10. Carry a 1. 2 plus 8 is 10. Plus 1 is 11. Carry the 1. 4 plus 1 is 5. So we know the chef makes $5.10 an hour. The question is, how much less than a manager does the chef make? So in order to figure that out, we have to do $8.50 minus $5.10. Again, subtracting decimals, we just line the decimals up, drop it in place. 0 minus 0 is 0. 5 minus 1 is 4. 8 minus 5 is 3. So we can see that the chef, to answer this question, makes $3.40 less than the manager. Again, nothing too hard, but a lot of hoops we have to jump through. In this problem, we had to work with percents and decimals, including multiplication and addition, to figure out, what was what. So, again, that's the ASVAB. It's 8th grade math. It's basically 3rd grade through 8th grade math, but you have to be competent in pretty much everything in 3rd to 8th grade. So, all right. Number 6 says a builder has a wooden board measuring 231 inches long. He needs to cut this board into 20 separate boards. What should the length of each board be? So we're going to do 231 divided by 20. Okay, so this is a fairly straightforward problem. 20 goes into 2, it doesn't, it's too small. 20 goes into 23 one time without going over. 20 times 1 is 20. 23 minus 20 is 3. We drop down this 1. 20 goes into 31 one time without going over. 20 times 1 is 20. 31 minus 20 is 11. Now we have to ask ourselves, how many times does 20 go into 11? It doesn't. 11's too small. We have to add a 0. When we add that 0, we have to kick up a decimal place right there. Now the question is, how many times does 20 go into 110? And at this point, let's just take a little aside here. We know our answer is going to start with 11. So this is not right. This is not right. The next number we find is going to tell us whether it's 1 or 5, in which case we'll be done. 20 goes into 110 times 5 times. 20 times 5 is 100. 110 minus 100 is just 10. We have to add a 0. 20 goes into 105 times with no remainder, since 20 times 5 is 100. So we can see that each board must be 11.55 inches. Again, nothing too hard. I think most people learn long division in 4th grade. Since we haven't been in 4th grade in a long time, you have to practice it to get good at it again. So, all right, number 7. Daria can wash and detail 3 cars in 2 hours. Larry can wash and detail the same 3 cars in 1.5 hours. About how long will it take to wash and detail 3 cars? It should be an if right there. If Daria and Larry work together, I'll fix this. So Daria can do 3 cars in 2 hours, which means she can do 1.5 cars every hour. Larry can do 3 cars in 1.5 hours, which means he can do 2 cars per hour. Combined, they could do 3.5 cars per hour. So this question becomes this: if they have to work on 3 cars, and they can do 3.5 cars per hour, we do 3 divided by 3.5 to figure out how many minutes that's going to be, because they can work at a combined rate at 3.5. There's another way to set this up. Let's see if I can remember how to do it, because I don't want to do 3 divided by 3.5. That can get messy. Yep, there's another way. So you could either do 3 divided by 3.5 like this, and then you can get 51 minutes that way, or you could do 3 out of 3.5 equals how many minutes out of 60. Okay, we can set up a proportion to convert this decimal to a time out of 60, which would be minutes. So we're going to go ahead and cross multiply. That is, we're going to do 3 times 60 and 3.5 times x. 3 times 60 is 180. 3.5 times x is 3.5x. Now we're solving for x, so we're going to divide both sides by 3.5. Okay, so now this problem becomes 180 divided by 3.5. And the way you deal with decimals when they're outside the division bracket is you move this decimal here once, and whenever you move the decimal outside the division bracket, there's technically a decimal here. We move this corresponding number of times. So in reality, we converted 3.5 to 35, which prompted us to make 180 1800. So in reality, we're working out this problem. Okay. And the way I like to think about these problems is this. Again, you have to be good about using some mental math skills to work out these big problems. We can ask ourselves, how many times does 3 go into 18? Or 118? That would be 6 times. But since this is bigger than 3, we know that it would have to be 5 times, because 3 times 5 would be 15. Therefore, 35 times 5 is going to be slightly bigger than 15. Let's go ahead and confirm that. 35 times 5 is 25. Carry the 2. 5 times 3 is 15. 16, 17. Okay? Again, I'm asking myself, how many times does 35 go into 180 without going over? 35 times 5 gets me 175. Okay? 180 minus 175 is 5. Drop down this 0. Now the question is, how many times does 35 go into 50 without going over? It's 1 time. 1 times 35 is 35. And we don't have to worry about this remainder, because we can see our answer is going to be 51 minutes. Okay? So again, if you're dealing with long division and it's getting messy and you already have your answer, just stop. You know this is 51. You can see the answer is 51. Just move on. Don't waste your time. Keep going, working this out to however many decimal places because you typically don't need to do that. All right, let's move on to the next one. I'm not sure combined rate problems show up that often on the ASVAB, but that said, I put this one in the test because I thought it was a pretty good example of how to do division with decimals. Okay. All right, number 8 says Kelsey got a 74% on her social studies test. The test had 50 questions. How many questions did she not answer correctly? So if she got a 74%, that means she got 50 times 0.74 correct. Again, we're multiplying a whole number by a decimal. The first thing I'm going to do is shift that decimal 2 times to make 0.74 74. So I'm going to do 50 times 74, albeit with 2 decimals to add back in at the end. 0 times 4 is 0. 5 times 4 is 20. Add a 0 since we're starting this number. 7 times 0 is 0. 7 times 5 is 35. Let's add. 0 plus 0 is 0. 0 plus 0 is 0. 2 plus 5 is 7. 3 plus nothing is 3. Shift our 2 decimals back in. 1, 2. So we can see that she got 37 questions correct. This question says how many did she not answer correctly. So we're going to do 50 minus 37. 0 minus 7 we can't do. We have to borrow 1 from there. That becomes 4. That becomes 10. 10 minus 7 is 3. 4 minus 3 is 1. We can see that this is 13. Okay, pretty simple problem. Probably one of the easiest problems in this practice test. All right. Number 9 says Al fills an ice cream cone to the top edge. The diameter of the ice cream cone is 2 inches and its height is 6 inches. Dawn fills a bowl, volume equals 5 cubic inches, with ice cream. How much more ice cream does Al have than Dawn? Use 3.14 for pi. So an ice cream cone looks something like this. And to figure out its volume, we have to know the formula. Volume equals 1/3 pi r squared times its height. The height is right here. We're told that that is 6. We're told the diameter, which is this entire distance, is 2. We only need the radius, which is right there, which is half the diameter, which is 1 for this formula. So let's go ahead and plug those things in. And again, the ice cream is just filled up flush with this face right there. So volume equals 1/3 pi. Radius, as I said, was 1 squared. And the height, as I mentioned, is 6. Okay, let's go ahead and work that out. Sorry about that. My email distracted me. Alright, so I like to simplify this before I begin. I'm going to take this 1/3 and multiply it by 6. 1/3 times 6 is just going to be 2. 1 squared is just 1. 1 times anything is just itself. So this all reduces to just 2 pi. Okay? And we're told to use 3.14 for pi. So let's go ahead and work that off to the side. 3.14 times 2. Again, we have a decimal multiplied by a whole number, so we have to shift this twice before we begin to make that 314 times 2, albeit with 2 decimals to add back in at the end. 4 times 2 is 8. 1 times 2 is just 2. 3 times 2 is 6. Shift our 2 decimals back in, 1, 2. So this is 6.28. We're told that, what's the other guy's name? Don had a bowl with a volume of 5. So to find how much more ice cream Al has, we do 6.28 minus 5. Since they gave us the volume already, which was nice, we can go ahead and work this out. 8 minus 0 is 8. 2 minus 0 is 2. Drop down our decimal. 6 minus 5 is 1. So we can see that Al has 1.28 more cubic inches of ice cream than Dawn. Again, this is one formula that is not very hard to memorize. And in light of that, I would say you should know how to find the volume of a cone, just to be especially prepared for the test. I know when I took Calculus 2, I pretty much had to know all the formulas for volume of all the common shapes. So eventually, if you work with the formulas enough, they become second nature. All right. A lot of these problems require you to think pretty critically, which is the point of this practice test. Number 10 says Juan has $40 in his jacket. Every day he spends half the money that is in his jacket. On the first day, Monday, he spends $20, leaving him with $20. On what day will he start with less than $3 in his jacket? So we know we start with Monday. We got Tuesday, Wednesday, Thursday, and Friday. Okay. And we want to know what he starts with and what he ends up with. So we'll go ahead and create a little chart, just so we can organize our work. We're told that on Monday he started with 40, he spent 20, so he ended up with 20. Again, he's starting with 20 here. He spends half of that, he ends up with 10. He starts with 10 here. He spends half of that, he ends up with... Oops, I think I made a mistake. Yep. Let me backtrack a little bit. Sorry about that. So he's starting with 10. Come on, pen. He's starting with 10 here. That means he's going to end up with 5. He's starting with 5. He ends up with 2.5. He's starting with 2.5. He ends up with whatever half of 2.5 is. Okay? So here's all the start days. He starts with 40, starts with 20, starts with 10, starts with 5. On Friday, he started with $2.5, which is less than 3, and answers our problem. Okay, so that's that one. All right. Number 11 is pretty difficult. It says a submarine left Hawaii 2 hours before an aircraft carrier. The vessels traveled in opposite directions. The aircraft carrier traveled at 25 miles an hour for 9 hours. At the same time, after this time, the vessels were 280 miles apart. Find the submarine's speed. Okay. So I'm going to break this down into this. We have a sub and an aircraft carrier. We know, if we've paid attention, that we have all the elements of the distance equals rate times time formula. We just have to figure out how to apply them. And in this case, we're not doing a combined rate problem. We have to figure these out separately. We're told, and let's go ahead and jot this down right here. We're told that the aircraft carrier traveled at a speed or rate of 25 miles per hour for 9 hours. So during those 9 hours, that aircraft carrier went a total of 25 times 9. 5 times 9 is 45. Carry the 4. 9 times 2 is 18, 19, 20, 21, 22. That aircraft carrier went a total of 225 miles. Okay? That means that the sub had to go, and let me go ahead and write this down, a distance, or traveled a distance of 280 minus 225. 5 minus 0 we can't do. We have to borrow. This becomes 7. This becomes 10. 10 minus 5 is 5. 7 minus 2 is 5. 2 minus 2 is nothing. So we know the sub traveled a distance of 55 miles, since the aircraft carrier traveled 225 of the 280 miles. We don't know how fast it traveled, but we know it left 2 hours before the aircraft carrier. The aircraft carrier traveled for 9 hours, therefore the sub traveled for 11 hours. Okay, 9, 10, 11. Now we can solve for r to find the speed of the sub. So we're going to divide both sides by 11. This crosses out. We're left with r equals 55 over 11, which is the same as 5. Okay? All right, so in this case, we had to use the information about how fast the aircraft carrier, or how far the aircraft carrier traveled, to figure out the rate at which the sub traveled. So not necessarily an easy thing to do for this problem, but nothing too difficult. All right. Number 12 says a rug, which is in the shape of a semicircle, has a diameter of 2 feet. What is the area of the rug? So a semicircle looks like this, more or less. We're told its diameter, and its diameter is this distance right here. We're told that is 2 feet. So if its diameter is 2 feet, its radius, which will be right here, is 1 foot. And again, a semicircle is just half a circle. So we can use the fact that we know how to find the area of a circle to find the area of the semicircle. The area of a circle is, as we should know by now, pi r squared. Okay. Again, we know what our radius is. It's 1 foot. But in light of the fact that this is the area of a circle, and we're trying to find out the area of a semicircle, a semicircle is half the area of a circle, so we're going to put this all over 2, which will cut it in half. So again, this is going to be pi r, as I said, was 1 squared over 2. Area equals 1 squared is just 1. Anything times 1 is itself. This is pi over 2. Again, you want to use 3.14 for pi whenever you have to use it on the ASVAB. So this becomes 3.14 divided by 2, which looks like this. And we could stop right here and say this is the only logical answer choice, but since we're practicing, let's work it out. Again, you only shift the decimal in long division when it's outside the division bracket. Since this one's inside the division bracket, we're just going to bring it up in place. Now we ask ourselves, how many times does 2 go into 3? It goes into 3 one time without going over. 2 times 1 is 2. Subtract. 3 minus 2 is 1. Drop down this 1, drop down this 4. Now the question is, how many times does 2 go into 11? 2 goes into 11 5 times without going over. 5 times 2 is 10. 11 minus 10 is 1. Drop down this 4. 2 goes into 14 7 times without going over. 7 times 2 is 14. Subtract. We can see that the answer is going to be 1.57 cubic feet. And this shouldn't be cubic. This should be feet squared. So I'll go ahead and fix that in the practice test. It should be 1.5 feet squared, okay? Since we're talking about area, not volume. So I'll go ahead and fix that one. Again, pretty straightforward that one was. Alright, this question, I'll be very honest with you, is one of the hardest questions you'll see on the ASVAB. If you're going to score somewhere between 90 and 99, you'll see questions like this. That said, as I feel for all these problems, if you passed 8th grade math, you should be able to handle this pretty easily. Okay? Well, this one requires some Algebra 1, so maybe 9th grade math. So let's go ahead and take a look at it. It says flying against the jet stream, a jet travels 1,880 miles in 4 hours. Flying with the jet stream, the same jet travels 5,820 miles in 6 hours. What is the rate of the jet in still air? And what is the rate of the jet stream itself? So again, we should recognize that we have all the elements of the distance formula. We have distance. We have time, we have distance, we have time, and we're being asked to find the rate of both the air and the speed of the jet in still air and the jet stream. So we have all these elements, as we did 2 problems ago. We just have to figure out how to use the information we're given to solve this problem. In this case, I'm going to set up another chart. It's going to look like this: distance, rate, and time. Okay. And I'm going to fill in what we know accordingly. This is going to be our against the stream. This is with the stream, the jet stream. I'm just putting these labels here so we can keep track of which is which. We know this distance is 1,880, and we know the time was 4 hours. Similarly, we know this distance is 5,820. We know the time is 6 hours. Now the question is, how do we deal with this rate when we have the conditions that we do, namely against the jet stream and with the jet stream? Well, in light of the fact that the jet stream either speeds you up or slows you down, we can use that information to build an equation that will let us solve this problem. Again, this first one is against the jet stream. So our rate of speed is actually going to be slowed down by the jet stream, which I'm going to represent as S. So again, this rate against the jet stream is slowed down by the jet stream itself. So I'm going to call that R minus S. When you're riding the jet stream or it's pushing you, that's going to speed you up. So I'm going to call that R plus S. Okay? And with that done, we can actually build an equation that's going to let us solve this problem. And I'm going to move down here just so I can do it. Again, we're working with distance equals rate times time. I'm going to rewrite this problem this equation to be this: r times t equals d. Again, I just took this d and moved it over there because it's going to help us set up an equation. So again, r is r minus s. The time is 4, and the distance is 1880. This one is r plus s. We know the time is 6, and the distance is 5820. Okay. So what I'm going to do now is distribute this 4 here and here, and distribute this 6 here and here. 4 times r is, and let me start moving over here, 4r. 4 times negative s is negative 4s equals 1880. 6 times r is 6r. 6 times s is 6s equals 5,820. Okay. Now we have a system of equations we can use to solve r and s. But that said, before we do that, I'm going to divide everything in this equation by 4 to simplify it. And I'm going to divide everything in this equation by 6 to simplify it. 4r divided by 4 is just r. 4s divided by 4 is just s, so this is r minus s. 1880 divided by 4 is 1880 divided by 4. 4 goes into 18 4 times without going over. 4 times 4 is 16. Subtract. 18 minus 16 is 2. Drop down this 8. Drop down this 0. 4 goes into 28 7 times. Therefore, 4 goes into 280 70 times with no remainder. So this one is 470. 6r divided by 6 is just r. 6s divided by 6 is just s. 5,820 divided by 6 is 6 goes into 58 9 times. 6 times 9 is 54. Subtract. 58 minus 54 is 4. Drop down this 2, drop down this 0. 6 goes into 42 7 times, therefore 6 goes into 420 70 times, albeit with no remainder. So we know this is 970. Now we have a system of equations we can use to answer this question. More specifically, I'm going to take this bottom equation, add it to this top equation to form a new equation without s that's going to let us solve for r. So let's go ahead and add these two equations. R plus r is 2r. S, negative s plus s is nothing. 470 plus 970 is 0 plus 0 is 0. 7 plus 7 is 14. Carry the 1. 9 plus 4 is 13. Plus 1 is 14. We have 2r equals 1440. Divide both sides by 2. This gives us r equals 1440 divided by 2. 1440 divided by 2 is 2 goes into 14 7 times. 2 goes into 40 20 times. So we can see our rate is going to be 720 miles an hour. Let's take a look at our answer choices. So we know the rate of the plane in still air is 720 miles per hour, which is this one. So with that information, we have enough to solve this problem. If you want to figure out how fast the jet stream's moving, you would take this 720 and plug it into one of these equations and solve accordingly. Let me do that real quick. We know the rate is 720 plus stream equals 970. Solve for S, which refers to jet stream. We're going to take 720 away from both sides. This crosses out. We're left with S equals 970 divided minus 720. 0 minus 0 is 0. 7 minus 2 is 5. 9 minus 2 is 2. So we know the rate of the jet stream is 250 miles per hour, whereas the rate of the airplane is 720 miles per hour. Okay? Fairly difficult problem. All right, couple more problems and we're done. All right, 14 says your grades on 3 math exams are 80, 93, and 91. What grade do you need on your next exam to have at least a 90 average on the next 4 exams? So to find the average of anything, you add up all the numbers, that is, you sum them, and you divide by how many numbers there are. So this is the shorthand way to remember how to find average. Average equals the sum of the numbers divided by how many numbers there are. In this case, we're asked to find what individual test grade will give us an average of 90. So we can plug this in accordingly. We want a 90 average. We know that our 3 test grades are 80, 93, 91. We want to know what this 4th test grade must be to get us a 90 average. Again, sum of all these numbers. There's 1, 2, 3, 4 of them. So this is going to be over 4. So now we just solve for x. To do that, we multiply both sides by 4. This crosses out. 90 times 4 is 360. Again, 9 times 4 is 36. Therefore, 90 times 4 is 360. This gives us 80 plus 93 plus 91 plus x. We're going to go ahead and sum 80, 93, and 91. Okay, 0 plus 3 plus 1 is 4. Carry the 1. 9 plus 9. Let's make sure I copied that right. Why am I carrying a 1? You don't need to. Sorry about that. 9 plus 9 is 18 plus 8 is 26. So this gets us 360 equals 264 plus x. Now we're going to take 264 away from both sides. This crosses out. 360 minus 264. Again, this is going to get us our x. We can't do 0 minus 4, so we have to borrow. This becomes 5. This becomes 10. This is 6. We can't do 5 minus 6. We have to borrow. This becomes 2. This becomes 1. 15 minus 6 is 9. 2 minus 2 is 0. So we can see that the test grade on the 4th exam must be a 96 in order to give you an average of 90. Okay, so that's that one. And that question type is fairly typical on the ASVAB, so you should know how to do that one. All right, number 15 says the cost to produce a book is $1,200 to get started, plus $9 per book. The book sells for $15 each. How many books must be sold to break even? So we know that the book sells for $15 dollars per book, and we know that the cost to get started is $1,200 plus 9 per book. So to represent this as an equation, we do 15x equals 1,200 plus 9x. This equation says at what point will these two things be equal? And the question is, how many books must be sold, which I represented with x, before they break even. So all we have to do now that we set this up is to solve for x. To do that, I'm going to take 9x and move it over here. This crosses out. 15 minus 9 is 6x equals 1,200. Divide both sides by 6. Left with x equals 1,200 divided by 6. 12 divided by 6 is 2. Just drop down those 2 zeros. So we can see that in order for the publisher to break even, they would have to sell 200 copies of the books to do so. So that's that one. All right, number 16 says, and I changed this problem, by the way. This used to be 78, which was too difficult in my opinion, so I reduced this time to 36. Okay, so if you took this test already and you got 78 here, I apologize, that was fairly difficult, so I reduced that a little bit. 16 says the half-life of medication prescribed by a doctor is 6 hours. How many milligrams of this medication is left after 36 hours if the doctor prescribed 100 milligrams? So half-life means after every 6 hours, the amount of the medication is cut in half. We know that 6 goes into 36 6 times. So there's going to be 6 iterations in which this medication dissipates by 1/2. So let's go ahead and get this set up. 1, 2, 3, 4, 5, and I'll put 6 over here. So after 6 hours, we go from 100 milligrams to 50 milligrams. Okay? Again, this is 6, 12, 18, 24, 30, and 36 hours accordingly. So these are our hours. This is our milligrams. Again, after 12 hours, it cuts in half to 25. After 18 hours, it cuts again in half to 12.5. After 24 hours, it cuts again in half to 6.25. And again, we should be able to do this math mentally. After 30 hours, it cuts into 3.125. So at this point, we can rule this one out as an answer. And now we have to cut this in half again. Here's where you want to be very careful. And we know half of 3.125 is about 1.5. So if we were just guessing, we could guess accurately. But at this point, it's not very easy to do this one mentally. So I'm going to go ahead and work it out by hand because I don't want to make a mistake there. 3 goes into 2 one time without going over. 2 times 1, of course, is 2. 3 minus, and again, when we're doing division with decimal and the decimals inside the bracket, we just bring the decimal up right there. 3 minus 2 is 1. Drop down this 1, 2, and 5. So it's going to be that. Sorry about that. I missed a 1 there. 2 goes into 11 5 times. 5 times 2 is 10. Subtract. 11 minus 10 is 1. Drop down this 2. Drop down this 5. 2 goes into 12 6 times. 2 times 12 is 6. and then R12. 2 goes into 5 2.5 times. So we can see that, oops, this is in fact the answer. Again, I got a little lazy because I'm getting tired. This is a fairly tedious practice test. But as long as you get to this point, which I worked out for you, you should be able to see that this is the correct answer. Okay? So again, you may have noticed that this test required you to be good with fractions, fractions, decimals, addition, subtraction, and all of those things that you learned between 4th and 8th grade. So in light of that, I hope you found this video helpful. If you did, feel free to give it a thumbs up. If you think my channel and website's helpful, also feel free to subscribe to it. In addition, you can always leave comments in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.